Hi everyone, welcome to homework 4.5. So today we looked at gravity and how gravity is represented. Remember that the distance using information about gravity can be found using our 16 to t squared for feet. And so generally this is what we're going to be looking at in these situations. So this first question, though, is really just asking you to analyze this graph. It says a rocket is launched in the air and its height in feet is modeled by the function h. Here is a graph representing h. Select all true statements about the situation. The rocket is launched from a height less than 20 feet above the ground. Well, right here would be 20, and so it does appear that the starting point on that y-intercept is less than 20. The rocket is launched from about 20 feet. It looks like it's a little bit less than that, so I'm going to say no. The rocket reaches maximum height, which is here, at about 3 seconds. And yeah, that seems a little bit after 3 seconds, maybe. The rocket reaches the maximum height after 160 seconds. So 160 seconds doesn't represent the time. 160 represents the height in feet. That is the maximum height, but it is not the time. And then the maximum height of the rocket is about 160 feet. So yes, that is the maximum height that we see there. So again, that's just reading that graph, which you all already know how to do. A baseball travels d meters t seconds after being dropped from the top of a building. The distance traveled by the baseball can be modeled by this equation. So it's just an example of this baseball that's being dropped here. So at 0 seconds, it would be 0. It has dropped 0 feet, right? Like it hasn't dropped at all. And this is again measuring the distance that it has fallen rather than how far it is from the ground. So in 0.5 then, we're going to do 0.5 squared times 5 gives us 1.25. I didn't do that the most efficient way, so we can also put this in as 5 times, let's see here, 1 squared. So that's just going to be 5. 5 times 1.5 squared, 11.25, and then 5 times 2 squared. You probably could have just done that in your head as 20. Okay, and so now we're going to graph this. And in this graph, we should see it going up because the distance that the baseball has fallen is increasing. So 0, 0, 0.5, 1.25, 1 is 5, 1.5 is 11.25, 2 is 20. All right. It says, is the baseball traveling at a constant speed? Explain how you know. So here we want to know, is this speed, that time per distance, is it the same everywhere? And so the answer is no, because notice that the distance it has fallen is greater during this time period. All right, so we're going to say no because it is not increasing at a constant rate, right? So the distance traveled is not increasing at a constant rate. All right, number 5, a rock is dropped from a bridge over a river. Which table could represent the distance in feet fallen as a function of time in seconds? So if we have a rock being dropped off of a bridge, right, then the distance in feet fallen is how far it has fallen. It doesn't have anything to do with how close it is to the water, right? That's not what it's asking. It's asking the distance in feet fallen. So this actually should be something that is increasing, so that can help us to eliminate that we're not looking at C or D. If it asks us for the distance from the river, then we would look at tables D and C. But since it's how far it has fallen, we're going to be looking at it as a increasing function. Now here then we want to look and see what is happening exactly. So remember, we should have 16 times t squared. And so 16 times 1 squared is 16. So that one works out here. This one doesn't look quite right. And then 16 times 4 is 64. So table B is going to be our best option. That shows us gravity. All right, number 6. Determine whether 5n squared or 3n will have the greater value when n equals 1, n equals 3, and n equals 5. Here you're just plugging these in. So 5 times n to the first power versus 3 to the first power. All right, in this case, 5n squared will be greater. I also totally wrote that wrong. Times 1 squared. This is what it should look like, and this should be 3 to the first power, right? So this would be 5, and this would be 3. Still, 5n squared is greater. So this would be 5 times 3 squared versus 3 to the third power. All right, so here we would have 3 squared is 9 times 5 is 45 versus 27. So again, 5n squared is greater in this case. And now when we get up to 5, you can plug this as 5 times 5 squared versus 3 to the 5th power, right? So 5 times 25 is going to be 125 versus 3 to the 5th power is 243. So now in this case, 3 to the nth power, that exponential function will always eventually outgrow our quadratic function. It says select all the expressions that give the number of small squares in step n. So remember, for these, when we're looking for that quadratic pattern, we want to find the step squared and then see what we're adding here. So in this case, it's the step n squared plus n, the number of the step. And so we should look for something that looks like this. So we can cross that out because that's linear. N squared would only give us part of that answer. This is also linear. N squared plus 1, that notice we have n squared, but then plus 1 would give us only 1 squared here, so that's not correct. Now this one is looking at it being n times n plus 1 on this side, and so this is true because this is n squared plus n, that is equivalent. F is also equivalent, and then this would be 2n plus 1, which is linear, so that would not work. Number 8, a small ball is dropped from the top of a tall building. Which equation could represent the ball's height in feet? So now we're thinking about how far is the ball from the ground. So we have some subtraction here. Now remember, negative 16t squared represents the force of gravity and then therefore gives us the distance. So we would look at B being our best answer here. Again, A is linear, C is also, technically exponential there, but and then H or D would also be linear. Okay. All right. Number 9 is use the rule for function f to draw its graph. This is just practice with your piecewise functions, so this is a review. I'm going to just copy this down here. So 2 when x is less than negative 2 and greater than or equal to negative 5. Negative 2 when x is less than 4. Greater than or equal to negative 2, and x between 4 and 8. All right. So it equals 2 when x is negative 5. So this is 4, 5, 6, 7. So 5 would be here. And then, so between here and negative 1, negative 2, between here and here, it's going to equal positive 2. All right, and we have a closed circle at negative 5. This is greater than or equal to, and an open circle at 2. Negative 2, rather. All right. And then it is negative 2, so down here, between negative 2 and positive 4. So that's going to be the line there. And it is closed circle here, and open circle here. And then it equals x between 4 and 8. So between 4 and 8, we are going to say that it's 4, 4. And then it would be 6, 6, 7, 7, 8, 8. So our line is going to look like this. And then it is greater than or equal to, so this is closed, and this is open. Okay, this y equals x means slope of 1, y-intercept of 0, so the rest of the line would theoretically be there, but we're only looking at it between 4 and 8. Number 10, Diego claimed that 10 plus x squared is always greater than 2 to the power of x and used this table as evidence. Do you agree with him? So in this table that is true, but no, because let's just find another number to prove that with. If we were to put 10, we'd have 10 plus 100 versus 2 to the 10th power, right? 2 to the 10th power is 1024. So in this case, if we give an example where that is not true, and we can also just say that we know that exponential functions outgrow quadratic functions. Number 11, the table shows the height in centimeters of the water in a swimming pool at different times since the pool starts to be filled. Does the height of the water increase by the same amount each minute? Explain how you know. So here we're going plus 0.5, plus 0.5, plus 0.5, plus 0.5. So yes, because it increases by 0.5 inches every second. Oh, sorry, every minute. Does the height of the water increase by the same factor? So the factor we would check by dividing. Since you know it's increasing by the same amount, you can probably suss out that this is going to be 1.003, and then 151 divided by 150.5 is, notice that they are close but not the same. So no, because the first minute has a factor of 1.003, 33 extended, right? And then the next period of time is 1.003, right? So the factor is different. Let's look also at 151.5 divided by 151 is also different, right? That number is changing a little bit. So not the same factor, and we can show that by dividing the later value over the earlier value. Again, that is how we find the factor. All right, so that's it for your homework. I would suggest that you review piecewise functions if you didn't remember how to do that, and then also remembering the difference between linear and exponential functions there as well. Okay, your code word for today is cave. That is your code word, cave. Happy homeworking, and I will see you on Monday.